So here we're announcing our latest QuickLink Professional 2020 version. Thank you for coming and having a look. What you just saw was a little history of QuickLink. QuickLink started in about 1986 or so under DOS and has gone through constant revisions and constant versions of Windows, and from Windows 3.1 to the latest 10. This is the latest offering that we have for QuickLink. QuickLink is kind of a multi-purpose tool. It is for editing NC code files, and throughout this video we'll call it NC code, G code, code files, tape files. They're all talking about the same thing. It has everything from the simplest things. The simplest, you want to open up a file and maybe do some edits on it. So here it is as a basic editor. You open it up. It is a syntax editor. In other words, it can show you the comments here are in one color, the letters are in another color, the numbers are in another color, and we got this new nifty little yellow highlighter on the tool changes. All of those can be disabled or turned off, changed or turned off if you don't like them. So as far as editing goes, it's like anything else. Your basic editing is the same no matter what you're doing it on. Many people, for lack of something like a QuickLink, could just use the simple notepad that comes with Windows. That's fine if all your changes are just very simple basic changes. If you needed to change the approach height there, that's all fine. What this offers above and beyond that, and I won't go crazy into them right here. We will be making a lot of videos in the future about different parts of the system, but this is just meant for an overview. You can do all the normal editing functions like cutting and copying and pasting, search, find something, replace it with something else. These are a bunch of commands for jumping around through the program to get to where you want to edit. Like you can say, find the next T, and it jumps to the next tool. But what you can also do that's kind of neat is jump to a tool, and that'll just find the tools in there and let you jump. I want to jump right to tool number 3. You're right to it. You're right to it down here. Insert, something to help you with comments, expressions, 2 plus 2. Put a file, insert a whole new file inside of this file. NC code macros are kind of a biggie in that you can store up blocks that you use over and over again and insert them into your program very easily. And it can even stop and ask you questions for the things that change, like what's the speed here, or what tool number do you want, that kind of thing. Again, that's primarily used if you're working on a manual program. If your program's already been written, maybe spit out of a CAM system, your biggest uses in here will probably be mass edits and then verification to make sure it's okay. But let's just finish along this line. I'm still in the insert here. Enough of that. NC utilities. These are where it shows the difference between a QuickLink and a notepad. These are commands. Most all of these are made specifically for NC code. Arithmetic. Add 2 inches to all the X's. Multiply the feeds by 0.2. Add or remove spaces from the program. Change what's at the beginning or the end of lines. Compare 2 files. That's always a big one in these systems. What changes did I make? I got part number 1, 2, 3 ABC -A and -B, and what the heck is the difference? Compare will show you the difference between the two of them. Feed and speed override. There's an example of what they look like. You can just say it. I want all of the spindle speeds to be, 200% or so over what I had. Okay, it just goes through and changes all the feed rates. File cleanup, to remove and rearrange things in or out of the file that you don't want. File splitter is a way of taking a file that is full of subprograms and splitting each subprogram into its own little separate file. Very handy for you can tell your machine, on most machines there's a command to say, okay, dump out all of the programs. Show me all the give me all the programs in one shot, in one big shot. You bring them in here, you say file splitter, it'll break them up into the proper pieces for you. Information just tells you about the file, things like the minimums and maximums it traveled, how big it is, that kind of stuff. Back to here. Information, make columns. Organizes it in columns, obviously. Reformat will change it from one format to the other. Resequence, to change, to add sequence numbers, remove sequence numbers, which has been increased in this version to allow for macros, if and go-tos in your program, block references when you're doing cant cycles, like for a roughing cant cycle, the beginning block and end block. It knows how to deal with all of those when it resequences. Rotate, mirror, scale, translate. Let me just do a very quick example of that. Let's get down here again to Tool 2. See how tough it is to scroll all the way down? It would have been nicer to just hit that little command up there and know where you were going. Okay, so here's what was the finished pass on here. I will highlight the finished pass, okay? And then you come over to the NC Utilities. You highlight the group of code, the code that you want, and you come over here and say, what are we going to change? All right, what's coming in is absolute right now. What's coming out, you can change it to put incremental if you really want to change them over. You set which plane it's in so it knows where the circular blocks are. And now you can tell it what you want to do. I want to rotate it around. I want to mirror image it. I want to scale it up or down. Or I just want to translate it a little bit here and there. Okay. So it's a way to change the whole thing. If you want it, I don't know. I'll just go to do a mirror and see what happens. Mirror it over the 90-degree line, the mirror it over the y-axis. All right, that just throws it all over the y-axis. What else we got? Swap is kind of like find and replace, except it's an absolute swap, where you could say the classic example is swap G02 for G03. You would normally have to do 3 steps to do that. G02 for something, then G03s to G02s, and then whatever that something was, back to G03. It just speeds up that kind of situation. B macro interpreter is an interpreter for the macro B. How clever. Macro B macros in your typical machines. Fanucs call it macro B. Everybody else has a different name, but most of them are pretty similar, where you can actually write a program full of macros, all of the variables and go-tos and all of that good stuff in it. The macro interpreter actually takes it and compiles it into a longhand, straightforward G-code program, G01, 2, 3, just your tools, just your basics, and allows you then to see it, to plot it, to know that it's what you want. And it's pretty darn complete. There are very, very few little items that are a little different here than macro B, but they're very few, and they're not commonly used things at all. Okay, so that's what the NC Utilities. And okay, so you've got it done. You've edited the program up to be what you want. I'm not even sure. Well, that's a good example. I'm not sure what edits I just did to it. I did mirror it. Can't even figure out what that's going to look like. But so now you want to do other things with it. In the past, we've always had, since the first version, the ability to do DNC, communicate through the serial port out to your machine. It does, by the way, for newer machines that have built-in networking. it does have a way to send it across the network in or out of the machine in the identical manner as if you were sending it in and out of a serial port, a COM port. I guess what's nice about that is that if you don't have to learn two different ways. It could be consistent in your shop that every time you go to a machine, you go to this, you have to send something to a machine, you go to the same place, same command. Without that, you'd have to use some different system, a different way of transferring the program into a machine that's an Ethernet machine or a Wi-Fi. Okay, so going to DNC is no more than just turning on DNC in that machine and hitting send. Okay. Once this has all been set up by the machine name, it knows which port to go to. It can deal with all kinds of multi-port devices, be they network devices or local USB switches, USB hubs with different ports on them. And there is even a mode available in here where you can say set QuickLink up in a permanent mode where it's just listening all the time. And you then go to your machine tool and you send out a tiny little 1, 2, 3 line program saying which program you want. QuickLink waits the appropriate number of seconds and then sends it right back to you. So you don't have to go running between the machine and the computer. That's all a part of this latest QuickLink. Okay. One of the next things we really, really wanted to push about this new version, one of the things we strove for from the beginning, is verification and plotting. Everybody now has some kind of CAM system spitting out, hundreds, thousands of lines of code. And if you edit it in Notepad, you really don't necessarily know how good that code is or just what it's doing. You're trusting that what you saw on the screen in the CAM system turned into the proper code to run. And it very well may, and it very well may almost all the time, but that almost will really come back to hurt you if there's a problem or an error in there. We wanted to make it so easy and so few steps that you just did it. It was just worth it to just hit 2 or 3 buttons and get a quick picture and say, okay, I know I didn't introduce something crazy into the code. Let's just go over the plot. Okay. And again, I'm not going to get into all of the features of plotting right now, but I'm just going to say fit the extents of it on here. Okay. So look at what happened. Here's where I messed with the mirror imaging this. I probably left a little piece of line or something in there that I shouldn't have, and that's how it ended up with this big arc coming over the side here. Let's go back to, you know what, I'm going to just kill it, start over again on it, say open. I could have done it from the menus there. Anyhow, so there's, and if we hit this, we'd see the plot. So in just a few, literally hit one button and there's a plot of it. Throw to a 3D view, hit the same button. There's a plot. I don't see any of those red moves going crazy way up or way behind. So I know none of my rapids are going crazy on me here. It's just a quick verification. Now you can do much, much more with this if you really need to nitpick it. If you've got a difficult, long job that you really need to scrutinize, the whole thing can be gone through by hand. I say go to the first tool and you can watch it line at a time. Over here you're seeing the line. Over here you're seeing what it'll do. Go over to plotting. You can have a coordinate display following with you as you go. You can put in tool images. All common end mills and turning tools and such, you can throw in tool images and watch the tools to make sure they're doing what you want them to do. You can take it to a real level of sophistication if you want, or like I said, if you just need to get it done, like I'm going to send it out to the machine, but I just want one more quick look at it. I think this is a great way to do it. It removes any of the steps. Even in prior versions of QuickLink, you had to go through several steps to be able to see this and then DNC it. Now it's all there. You would say, okay, looks good. Hit DNC and hit send. You're off and running. Okay, so let's go back. Let's finish. So we talked about the NC utilities, DNC, plotting. Again, just mentioned some of the features you can have there, and all of these things are changed. This grid on the background, the axes down here. There's a lot of things you can customize. The plotting also can do a very, very accurate cycle time. It's been basically worked on and perfected for since about 1986. It started as far back as QuickLink did, and there are many things about it that you can tweak to get good results. If you're not getting good results, it probably still needs tweaking, which we would be glad to do. If you send us a sample or two, we will gladly tweak the settings till we get things in there properly. Okay, so I guess that's enough on plotting. And just to mention, the last mode here was just notes. Okay, notes is a very simple, basic word processor, kind of like WordPad that comes with Windows. It lets you add notes, pictures, all kinds of information to the job. All of these things are stored together in a private little folder just for this particular NC code file. So it allows you to keep them associated with each other. With notes, again, you can put graphics in, paste pictures into it. Anyhow, like I said, those are saved with the job. Going back to edit, plot, good enough. Speaking of edit windows, you can have as many open edit windows, each doing different things, as you'd like. I imagine the most common uses would be if you had a piece of one program that you wanted to copy and place it into another, and then tweak it up to be what you want. That might be a common use. Or just you're rolling along here on this piece, and this we've seen a zillion times here. This one like this, and someone comes along and says, no, that one you just sent me, what does that do? What does that one look like? You can just open it up. Here I'm going to open it up and mention while I'm at it, one of the features of the new version is that it will plot lathe cant cycles. It always did the threading, but now it'll do the facing and turning rough cycles. It just gives you some lines to show you where that's going to happen, and just by the virtue of the fact that it shows you the shape, you can see that you basically have your outline of the part you defined correctly. And see here, I'll just do a quick one of pulling this one up. It's a very simple job. So that's just the outline there. You can see from here, it's just that. G71 does all of these passes in here in the green. And down here, does this have a, yes it does, it has a G70 to do a finish pass back over it. Okay, so the beauty is that you could now, I don't know, he came in and told you that he needs a little greater depth of cut on this. Change that D to 750. Now we see it change the depth of cut. He agrees, everything looks fine, nothing got hurt, and you want to send it out to the machine, DNC, send. All while the other one is still sitting there. In fact, you could have them, let me put it back into plotting, you can have them sitting next to each other. Let's take up space for this one that we don't even need. All right, so let's just take this and say sit them next to each other, and you can pull them both out to their extents. This would also work out if you had a long plot. If you wanted to do a long plot of a lot of blocks, maybe even show the tool image so it slows it all down quite a bit, you could have one window just sitting here plotting away on your job, while the other one you're working away on something else. I'm going to close it up. Okay. One of the things I didn't mention now, when loading files, we have a new feature, Special Open. Special Open actually kind of stretches out instead of the normal little Windows file open box, which is very good and very powerful, but it adds something for specific to the NC code that you're working on. In other words, here, if you have plotted it, looks like I haven't plotted most of these. How's that? All right. So the mil2 that we just plotted, it retains a little picture of it, a little screenshot of the last plot. And here's the code that's in it that you can take a quick look at. You can find information in there, copy to clipboard, and the program is copied, and you can paste it into something else if you need to. Rename and delete is a way of obviously renaming or deleting the file that you're looking at. What that also does is take care of all of the, we call them assets. The assets would be the preview picture, the notes, the settings that you're using on that window, the settings you're using for plotting. It stores all of those things in what we call assets. And if you use this command, rename or delete, it knows how to do the same to all the assets. Keeps everything connected together. All right, and the last area to go into, we're going to go into the calculators. What calculators are for is, as I mentioned before, there's all kinds of CAM products out there, everything from simple useless ones to simple very usable ones to elaborate expensive ones. There's everything out there. But for better or for worse, there's still a class of jobs that people can do and like to do mostly by hand. As long as I've been at it, every other lathe programmer I ever met in my life says, I don't use a CAM system. I just use the CAM cycles and boom, boom, boom. I'm all set to go. Okay, we're not going to fight you, but we can give you things to help you along with that. And the calculators. These are all things to help you with getting the body of the program in there. It is not a CAM system full of post-processors and elaborate operations and 3D machining and all. It's nowhere near any of that. But it is helpful, is a helper for many of the common situations that you're into. Basic motion is mostly all for people who are really, really, really starting out. If you're not quite sure what basic, linear and rapid line should look like, you can just put in the actual coordinates you want to go to, and then hit the button, and it shows you what the line looks like. I'm just going to do something very, very simple, just to do it. We'll say it's a linear move, and the feed is 6 inches a minute or whatever. If you say next, see it's right here. Copied, ready to go. There's the line all formatted. Basically, same thing for circular blocks, same thing for drilling and tapping. Offset is a little more sophisticated. With offset, you can enter in, basically you're entering in 3 points: start point, middle point, end point. It'll figure out the tool point to the left or to the right by giving it the tool size. It'll give you an offset point to one side or the other. Again, handy for people who are kind of intermediate, getting to know it, but still have a little trouble with the trig. One neat trick it has is you can say fillet radius, and it actually throws a radius in where the middle point is. So now you get all of the blocks to come up, to approach, go around, and move away from the radius. So it kind of a nice thing to have. I'm just going to cancel it. Calculators, circular pocketing and hole. Very full featured. This is right out of our CAM product, Power Station. Lets you rough or finish a hole. You can do it as concentric circles. You can do a spiral made out of arcs, which is a little different, or helical, a true helical the whole time. Moving down in X, Y, and Z as it goes around it. Rough, finish, control over direction, the number of passes, the depth of each pass, on and on and on. Full control over all the parameters. Later, drilling patterns are all your classic drilling patterns that everybody has. Bolt circles, linear, grids, a rectangle full of holes. Not even going to waste your time. Although I might, let me just show, just real quick, just let's do the old bolt circle that everybody and their brother does, just for the heck of it. Just to say, okay. And it automatically throws that out, and we keep calling it the Quick Link results window over here. Every time you use one of those commands, when it's done, it throws it out into a command. You can very easily just say, I'll cut it out of there, and I'll just paste it into this program I'm working on. Okay. Calculators. Again, I won't go. I'm going to jump over Geometry Workshop for a second. Engraver allows you to do text engraving in a bunch of different fonts. Again, generating all the G code for that. Lathe facing for simple, straightforward lacing. You can do it by hand, but it's boring as anything. It'll speed that up for you. Mill facing allows you to clean off the top of a block, zigzags back and forth the top with control over which direction, things like that. Rectangle pocket is a pretty complete one. It lets you do rough and finish, multiple depths if you have to go down, which direction are you cutting it, and radius in the corner, and a helical entry if you want it. I'm going to take and do the whole smash on one real quick here. How about a corner radius a little bigger? 0.75, not 785, 7.5. Come on now. 0.75. Okay, and just to show what it can look like, I'm going to say good. Okay, generates all my blocks to do that. I left this window set for a lathe when I used it before this all started. I'm going to set it back to dmill or mill. And boom, there it is, pocketing out that rectangle I just described there. You can see the helical entry into it, and then the passes around to make it up. You can do the same thing here. Copy this, bring her down here, and paste it in here. Okay. Again, it's a manual. It's a place to mix a little help from the computer with a little help from the manual end of things. All right. T2. Different speed. Okay. Again, just showing how you can build up a program yourself here. Now we've got a pretty good program going on. What else do we have here? Calculators. We have Quick Calc, which is just a calculator. That's all it is. Speed and Feed Calculator, which has been around in several of our products, allows you to go in and change things like a spreadsheet, change the tool diameter, and everything else. Everything else updates to match what you've done. Calculators, Speed and Feed. Thread Cycle is kind of a neat one. What the thread cycle lets you do is two things. It lets you create a new threading can cycle. It also lets you update an old one. What you can do is, so let's take it. So let's start with the simplest use. You've got all of these settings over here. These are all the standard settings you'll see on any of the can cycles. You say what one you want. I want a FANUC double line type one. And it generates the cycle from the information that you placed in here. Okay? And if you say OK, here it just squirted it right into the program we were working on. Look at that. Right, that mill program threw that cycle in there. But here's what you can also do. All right? Suppose you had this cycle like this already, and you wanted to change it. You're bringing it from your machine that had a single line to a machine that this is a double line. You're taking it from this machine that has a double line, and you need to run it on your single line Haas. You can simply go to Calculators, Thread Cycle. All right, it already has that in there. You say Import, and it takes in all the settings from this double line one. And then you can say, okay, I want it to come out as a Haas single line. Generate. So now it's translated the Panic double line into a Haas single line. And there are several selections in there. I'm sure we'll be adding a lot more as time goes on. These are just the real common ones that we threw into, you can say OK, and boom. See, now it's in a Haas single line format. All right, get rid of that because we really don't need that on a mill. And what else do we have? Our thread milling, always very handy, and you can generate it as incremental or absolute. It's nice in incremental so you can reuse it at different locations very easily. Let me just pull it up for a second. It has all of the standard stuff about the major diameters and where the hole is located and stuff. And on the entry and exit, it'll do a line into a radius, a sweep into it. It'll throw in the G41 or G42 for you. It creates pretty darn complete thread milling cycle. And now for the granddaddy of the calculators, the Geometry Workshop. Geometry Workshop is a place where you can build or work with freeform geometry. Points, lines, arcs, drawn in the Geometry Workshop or drawn in your favorite CAD program. It opens and reads DXF files. So the simplest use of it might be to say, open a DXF file. I've got this classic one that's been around forever with a little bit of everything on it. Basic thing you might want to do is push a tool around it. Especially with a note for people who have controls that don't have cutter compensation, this will generate the offset path. So you don't need it in your control. It'll generate the offset path for the tool diameter. Anyhow, let's just look quick at that. You say tool path, generate a tool path. It automatically selects everything. If you don't select ahead what you want, it automatically selects everything. I'm cutting a boundary. I'm going to say cut it on the left side. There's all the stuff about the tool diameters and Z's and feeds. Okay. Start around here and head away. It always heads away from where you start. So I'm starting near this end. It heads the other way. That blue line you see there is now the tool path around the part. You can say File, Generate Code and Exit. We don't have to save it because we loaded it in from there. So there's code to go around that shape. If you want to plot it real quick, you can certainly do that. That's a big time saving. There's a lot of, it's not all the most difficult trig in the world, but there is a lot of trig and a lot of figuring to get around shapes with a lot of tangent points and intersections and things like that. Let's get back out of here. Let's go back into the Geometry Workshop and look at what else we can do. It has, let's clear this one out. It has built in 2 geometry creation utilities, Easy Geometry for mill or for lathe. These are similar to the assists that you see on many controls. Instead of talking in raw X, Y, or Z coordinates, you're talking something more like what you're making. On a lathe, for example, you're talking about a diameter to a shoulder, to a fillet, to a taper, you speak in those terms. I'm going to load in an old file just to show what it looks like. Okay, see how it's said from a 1-inch diameter to a chamfer this big, then a shoulder, then a radius, then a taper. Once you get these in here, you say show, and there they are. Okay, it basically previews that for you. All right, that's the geometry I want to create for you. Say OK, and you're plunked right back into the Geometry Workshop with the geometry in there. Now you could modify that geometry or just go ahead and again generate a toolpath on it. Then there's also, you can start from scratch if you just want to make some kind of a geometric shape in here. You have something with a couple of little, again, tangents and intersection points on it and such. You can actually draw it up in here. I wouldn't call this a full blown, nowhere near a full blown CAD system, but it is a place where you can draw the necessary 2D geometry for your fundamental 2D machining on routers and flame cutters and mills and lathes. It works on all of them. So I'm just going to invent a little shape just to show you basically some of the types of things you can do. Let's put a circle right at the origin there, 0, 0, start by the coordinates. There's a circle. I'm going to put another circle in, this time just by the cursor. I could certainly use coordinates or anything I want. I just want to give myself something to work with. All right, so now I've got a couple of circles there. I'm going to draw a line tangent to 2 here. So line tangent to 2. Select 2 arcs, or 1 point and 1 arc first. Okay, that sounds reasonable. Here's the 2 things. You can click on one, hold the shift, and click on the other. So now I have 2 circles selected. Circles, arcs. Draw line tangent to 2, somewhere around there to somewhere around there. Gives me that tangent line between them. Draw an arc tangent to 2. Did it again. See, I keep forgetting. Glad it reminds me. Now I have 2 arcs selected, 2 circles selected. Draw arc tangent to 2. The radius, it's got to be a pretty big radius to go on there. I'm going to say 6 inches. And again, it touches somewhere around here, somewhere around there, and the center of the arc somewhere up here. So there's my pieces of geometry. Let me bring that all back on the screen. Okay. Now I'm going to zoom back in because it makes the next command a little better. You can clean this up to work on it. You really need to clean it up to work on it, I should say. So this is one of my edges. This is another one of my edges. And I say modify, trim. Okay. I want to get rid of that. I want to get rid of that. I want to get rid of that. Okay. Getting there. Escape. Now let's do the opposite. I want it. That's one of my trimming edges. That's my other trimming edge. And modify, trim. What do I want to get rid of? That and that. Okay. I now have a nice smooth shape. So now we want to generate the toolpath just like before. I say toolpath, generate. Do to the left, same type of thing. Except I'm going to start over here because I want to head that direction to the left here. So start near this end. Boom. There's my toolpath in the blue there. If you really want to see it, you can show the little tool images there. Help you see where the points are. You say generate NC code and exit. No need to save it yet. It's still in there. I'm going to go back to it. And here's the code it generated. And I can look at that code and I see the shape that I made. Okay. Let's get out and go right back in. One more thing, just to show what's there. Under the toolpath, let's look at the different types of toolpaths at this point. Cut a boundary, which is what we did when you're going around on a mill or an XY type of machine, around a continuous boundary. Cut all entities, that's more for freeform geometry, like a logo or something like that. It does not offset for the tool. It strictly cuts everything on line, but it will jump between, if you ask it, different sections of the part. It's good for things like engraving. Engraving a logo might be a real good example. Drill all points is where you can draw points up on the screen here and tell it to drill all points. It does a slightly optimized version of the drilling. It starts at the point you indicate and then keeps going to the nearest point. It's not a full optimization, but it's pretty good for your basics. OD turning, ID boring. They're just specialized versions of this cut boundary that asks you in terms of the tool radius and whether you're working on the OD or the ID. It puts out the proper format and codes for turning operations, and that's it.